All right, so this is the second of 3 videos. This one here, we're going to be discussing how to find the angle between two lines. So what I want to do is I want to kind of chart out how this equation came to be. Where did this equation come from before we get into it? So first thing we're going to do is we're going to draw a x-axis and a y-axis. So draw an x-axis and a y-axis, and then I'm going to draw a random line. We'll call that guy line 1. Now you'll notice that line 1 actually has an angle, inclination. We'll call that guy theta 1. And then we have a second line, and this second line right here is going to be this guy. I'm going to call that guy line 2. And line 2 you'll notice has an angle, inclination that we'll call theta 2. Now our job, our goal today is to figure out what is the angle right in here. That's really what we want to know. So I'm going to call that guy theta. So we're going to say that theta is equal to theta 2 minus theta 1. And that kind of makes sense because if you take the blue and you add the green, then you get the purple. Or if you take the purple and subtract the green, you get the blue, and that's what we have right there. But if you know that this is true and you took the tangent of both sides, what you would end up getting is the equation, the tangent of theta is equal to the tangent of theta 2 minus theta 1. And then if you go back and think about your, your trigonometry, your identities, your, what do we call that one? The difference identity right there, kind of like the sum identity. What you end up finding out is that the tangent of theta 2 minus theta 1 is equal to the tangent of theta 2 minus the tangent of theta 1 divided by 1 plus the tangent of theta 1 times the tangent of theta 2. And then this is going to lead us to an even more simple equation rather than having all these tangents here. If you recall from the last video, from the last section, that the tangent of theta 1 is in fact just equal to the slope of that first line, and that the tangent of theta 2 is just equal to the slope of that purple line. So you can rewrite this equation, and you can write it as that the tangent of theta, the tangent of the angle between the two lines, is in fact just equal to the slope of the second line minus the slope of the first line divided by 1 plus the product of the first slope and the second slope. And this right here is the equation that we really want to make sure we understand how to use. So tangent of theta, the tangent of the angle between my two lines, is the slope of the second line minus the slope of the first line divided by 1 plus the product of those two slopes. So how would this problem work? Well, this is our first example. Example number 1. Suppose we had two lines. Line number 1 is y equals 3/4 x minus 10. And then we had a second line, line number 2, which had an equation y equals 5/2 x plus 1. And I wanted to figure out what is the angle between these two lines. Well, if you wanted to visually see what's going on here, you could take a graph and graph these two lines. So -10 up 3/4. Something kind of looks like that. And then you have another line, y equals 5/2 up 5/2. And what you end up getting is a line that kind of looks like that. And we're trying to figure out what is this angle, okay? So that's really what we're trying to figure out. That's visually what's going on here. Now we can ignore that and we can just say, okay, well, we're trying to find theta. So if I was to write out my equation, all I'd have to write out is the tangent of theta is equal to the slope 2, the second slope, so 5/2 divided or minus the 3/4. Right, so slope 1, slope 2, divided by 1 plus 5/2 times 3/4. Now something I forgot to mention earlier was that m2 minus m1, because the order doesn't really matter, what we're going to do is we're going to put absolute values in there. So we're going to put absolute values into the equation because all we want is the angle, and the angle is always going to be positive, so it really doesn't matter if you do theta slope 2 minus slope 1 or slope 1 minus slope 2. The only difference between the two is one's going to give you the angle this way, which will come out negative, and one will give you the angle this way, which will come out positive. So by putting it as absolute value, the angle is not going to have any direction involved in it. All right, so we almost have it. All we have to do now is find out what theta is. So we say theta equals the inverse tangent or the arctangent of that crazy looking fraction. 5/2 minus 3/4 over 1 plus, I guess we could simplify that. It doesn't really matter. 5/2 times 3/4, because we're just going to plug it into the calculator. Now, if we weren't plugging into the calculator, I'd suggest trying to simplify that thing out a little bit better. Common denominator, trying to essentially make this a single fraction. But we're just going straight to the calculator on this one here. I went ahead and plugged it in. So we have the arctangent of 5/2 minus 3/4 in absolute value. Probably don't want to forget that, so I'll go back and rewrite it. And then over 1 plus 5/2 times 3/4. And then after it's done, we end up getting 31.3. So what we'll do is we'll write down that theta is equal to 31.3 degrees. And then just to keep things consistent, put the absolute values around that. So don't want to forget about that. This is essentially how you find the angle between any two given lines. If you have any questions on this, please email me. And if not, please take a look at the assignment. There's one more video. The last video should be on finding the distance between a point and a slope, not using the rigorous geometry method of doing this, but actually looking at it from really closely to the way we do it in linear algebra. But we'll take a look at it with a special equation. All right, best of luck on SBAC. Talk to you guys next week.